Hello, and welcome back to Python with another series regarding data science. And yes, today we are looking at the Panda package. This has nothing to do with a cute little animal, but stands for Python Data Analysis. So as the name suggests, Panda is an open source manipulation and analysis library for Python. And yeah, has many similarities to Numpy. So if you're coming from Numpy or already learned Numpy, Pandas is perfect for continuing, because now we are finally getting to the interesting stuff, now interacting with Excel files or even being able to create new Excel files. And yeah, installing Pandas is pretty simple. You just have, I will type it as a comment. You have just use your console and type in pip install pandas, or if you're as lazy as me, just open any project with your IDE, and in PyCharm it's possible to just import pandas. And yeah, if you move your cursor of your mouse onto pandas, you can install the package. And now PyCharm is installing the package just for the project I'm working on, but that's enough for this tutorial series. And now it's finished. I didn't even have to pause the video. So in this series we will work with Numpy and Pandas. So if you are new to data science, I recommend watching first the Numpy series. In this part of the series we are just handling the most common main data structures of Pandas. And yeah, so today we are looking at Panda series and Panda frames as structures. And for that we are working with lists and dictionaries in Python. First, let's create our first list. We call it the list equals 1, 2, 3, 4, 5. And yeah, let's create Dobby the dictionary, which is you will be shocked to hear that it will be a dictionary. I just skipped forward because the typing was not necessary and I forgot the comma. Yeah, so we will use to create our data structures, we are using the list and the dictionary. First, let's create our first Panda structure, which is the series. So our first series equals PD. By the way, let's import pandas as PD. PD point T series. No, I'm just stupid. Series has to be uppercase because it's a class. And yes, as an input, let's see, he wants any data. We can, even like in Numpy, we can define a d-type. So let's just put in the list. List is a list. Let's run the code just for looking if everything went right. It does. And now let's print our first series. And yeah, it works quite well. And yeah, he doesn't even print only the numbers, he prints the index. So yeah, let's print the index right, so it index always begins with 0. Perfect. So, like I said, he is already printing or giving us the index in the left column, and in the right column it is our input. If we alter our input, the right column changes. So let's undo our altering and let's get to the data frame. Let's create our first data frame. Equals pd point data frame. The dictionary is our input, and let's print our first data frame. Perfect. Now you can look at the output as your personal worksheet, beginning with the first column and the second column. And what's really important is that each list, first of all, each key of the dictionary, you are creating a data frame, because a data frame you should use a dictionary as an input. And each dictionary should contain one key, which should be... Oh, I didn't even try it out yet. What will happen if we are using an integer? Nothing. The integer works as well. So any key should be possible, but key, which can't be a list, of course, because a list is not hashable. Oh, I misclicked. But strings, integers, floats will work. But what won't work is if the length of a list is not equal to the length of the other lists, or let's just say each list, each value of the key has to be in the same length. So let's just create an arrow. He creates a value arrow. All arrays must be of the same length. So we can, if we want an empty cell, if a cell should be empty, we are using none, which is the same as... Oh, I already created a space for that. We are just using none, which is comparable to null in Java, for example, or null in C. And now he gets us none. So we can also print a certain column of our data frame just by typing in, for example, name, like we would do it in a dictionary. And now we are getting the index, still the index, but only the column which has name in it. And we can also use describe to get the type of each object in the column. So now he's counting each cell. Each cell is unique, top is Hubert, and so on. So this is kind of cool if you are, for example, having a sheet which contains really much empty cells and identical data. If you want to calculate with it, this can be quite useful. Kind of similar, but also different. Okay, you can't do anything with that information. There is the info method, and let's just try out what does give us the info method. It gives us even more information, like the how much memory is used for our column, and how much non-null objects are in the column. There are 4 because one is none, like already said, and so on. You can try it yourself by using different values, d-types, and try it for yourself, because in the next video we are gonna We are gonna look at Excel sheets and CSV files and how we import them, how we create new ones. I don't really know if it's just one video or if we are splitting that in different videos, but yeah, during these videos we will learn new functions, new types, and yeah, thank you very much. Thank you very much for watching my video. If you are wondering why I'm pronouncing certain things so strangely, I am still sick a little bit, but it doesn't help. And yeah, I still wanted to make videos because they are fun to make. Have a nice evening, dinner time, night time, morning time, breakfast time, lunch time, whatever time it is. See you in the next video. Bye bye.